Hello, this is Eric Harashevsky, and I'm going to present for you the PCAP Packet User Database. The PCAP Packet User Database, the PUD as I call it, is a digital forensics utility. First, a little bit of background. Manually investigating a network packet capture is quite tedious and time-consuming. Even using something like Wireshark still takes a significant amount of time trying to figure out the timeline of events and how they relate to particular users. Numerous technologies, such as network address translation, IPv4 to v6 translation, virtual private networks, and others, cause multiple user interactions to get mixed up together and appear quite similar. For example, they have the same source IP, and oftentimes the headers get rewritten. A PUD tries to make this investigation a little bit easier. This utility takes a raw PCAP data capture and imports it into a SQLite database. It reconstructs various TCP transactions and uncompresses the payloads within the hypertext transport protocol. It builds DNS information up from the UDP packets in the capture. In this way, network resolution can be performed identically to how it was done when the data was being captured. This utility also generates a higher level of grouping of these web transactions in order to create a more thorough and accurate timeline of individual user interaction. It uses various artifacts of the capture, such as HTTP headers, including the user agent, language, cookies, referrer field, as well as providing analysis and statistics of email addresses located throughout the capture. This chart shows the three major classes within the utility. The database class is used to read in the raw PCAP data, store it, organize, and help process this data. The packet class is used to start and performs basic packet analysis, such as reconstructing the TCP transactions and extracting the UDP packets that contain useful DNS information. The user class is then used to perform the higher level analysis, such as grouping these transactions into larger timelines via the various headers and other artifacts mentioned before. This class then is also used to export data and summary reports and raw timeline data. It can also be used in an interactive manner with the Python interpreter to actively investigate a forensics case. And next, I'm going to show a short demonstration of how this utility can be used. And now for the fun stuff. I'm going to show you a short demonstration of how this PUD, of how this forensics utility that I call PUD works. To start with, you'll want to extract the archive to your Linux host. It's possible, of course, to use this on Windows. However, I've only tested this on Linux. It is a Python script. It is a Python package. As you can see here, there is a package directory that contains the three classes, the database, packet, and user class. The root directory has a very useful README file. I highly suggest you take a look at it as I try to describe this utility in a reasonably thorough manner without getting too complicated. Back to the utility. The main utility is the pPUD, the pPUD.py file here. If you try running it, you'll get a nice summary of help. To start with, you can see up here there are three main options that you'll want to use. The first one is going to be the -pcap option. This is going to load a PCAP file into a database. This will also take a significant amount of time, as it does most of the processing at that stage. Afterward, you can run a -report or a -dump and generate various information. It's highly suggested that you also use this utility interactively, as you can run each individual function by itself, and there are a few extra utility functions built into it. So to start with, we're going to use that -pcap option to load in a new file. We're going to use that Nitroba PCAP that we used during class. And I'm not going to specify a different database file name, we'll just use the default. So this particular process, I know offhand, will take about 11 to 12 minutes. So and now the utility is finally completed, reading in the PCAP file and fully processing it. As you'll notice, it actually took 11 minutes, or 11 and a half minutes in this particular case. But now we have a fully useful database file. You'll see the database file right now is labeled P here. If you go back to the utility, you'll notice there's two major options that you're going to want to try and investigate after this point. And that'll be the report and dump fields. I suggest the first one would be the report summary. And I'll put this into a summary log file. You'll notice it gives you a brief rundown of the type of packets and counts, as well as all of the IP addresses and the source and destination packet counts. This could potentially give you an idea of the next step you want to take to your investigation. If not, you can always come back here. And another very useful item is the email statistics. We will generate a report email. And we'll use all email addresses, so we're not going to bother doing the email search. You'll notice that happens very, very quickly. And here you get a count of each email address, as well as where it's occurred in a sequence and stream. This is a good point to take a little step back and describe this concept of stream and sequence for this program. The stream is used to denote the actual TCP sequence, that is, the sequence of packets that had an incrementing sequence and acknowledgement field. The sequence item here is actually the higher level grouping of these streams. This is This is the sequence that is generated by looking at those various HTTP header fields like cookies and so forth and so on. Scrolling through a bit, you'll notice there's a bunch of those jcoachj email addresses. And look at that, there's a Lily Tuckridge. And Lily Tuckridge has one at sequence 153, and jcoachj has one at sequence 153. Well, in that case, let's take a look at sequence 153. So to do that, remember it's sequence 153. We will go back here and we will run a report sequence, and we will specify sequence 153. If you like, you can scroll through it and see all the various web pages and IP addresses that were in the particular sequence. If you decide this is a very interesting one, what you'll want to do is actually perform a dump and get the full details. And scrolling through this, you'll probably find some very interesting tidbits. I'll leave it at that for now. So another interesting way of using this tool is through the Python Interactive Interpreter. What we'll do is we'll start Python, and from the main module we're going to import. What this is going to do for us is instantiate the PUD package and make a PD database object, a PP packet object, and a PU user object. In this case, one of the more interesting objects here is the user one. You'll notice it has a few interesting utility functions. One is DNS Lookup. The DNS Lookup does not do a network lookup. It uses the UDP packets that are stored in the database to perform the same lookup that would have been done through the network capture. So what we'll do is we'll look up something using that. And I know there is an Amazon.com. And there you go. All of these various IP addresses include Amazon.com somewhere in the name. Just to do the opposite, you can use IP, and let's take this one for example. And there you go. This utility is being released as open source GPL. Please provide any feedback you might have. I'm certain there's all kinds of bugs. You're welcome to email me. You can also check the updated status of the project at the website shown on the screen.